All right, ladies and gentlemen, good evening, good morning, good afternoon, and welcome. Let's get started. We're on lesson 2.2 now, solving one-step equations. And of course, I am Mr. Stiger. So if you guys, ladies and gentlemen, please get the bell workout. We're going to do it again in the upper left-hand corner. Please put lesson 2.2. Pause the screen, please, and answer these questions. All right, so ladies and gentlemen, remember, this is for your benefit, okay? I gotta make sure I'm checking with you constantly, showing you stuff again, ensuring you guys know what it is. So 1/2 a number. What type of number? I don't know, you can use X, A, or whatever else you want. Minus 10 equals what? The same number. Translate the sentence into an equation. The sum of C, so sum of C and twice D, 2D, is the same as 20. Pretty simple, ladies and gentlemen. Hopefully you guys got these. The sale price of a bike after being discounted 20% is $213.20. When I look at this, ladies and gentlemen, this pops out to me right here. Is always equals $213.20. All right? In your brain, please remember, if you see is means equals, write an equal sign down and go. Write an equation where you can find the original cost of the bike B. So if I know this is over here, the original cost is over here somewhere, and if I multiply that by 20% or 0.20, ladies and gentlemen, I would have the original cost of the bike. Now, does it ask you to solve it? It does not. It just says write the equation. So you can rewrite this if this is bothering you. So it would be 0.20b equals 213.20, but you guys get the gist, okay? That is the equation. You solve it, and how you solve that is what we're talking about today. So we're going to be using a lot of mathematical practices today. 1 and 2, understanding and persevere, logic and reasoning. Because we're going to start doing one-step equations today. This lesson should be really simple for you guys. If it's not, I want to make sure that we get through these because before we get to multi-step, we have to make sure we can focus heavily on doing one step at a time first. So in your books, we're on page 87. At the top of your notes, ladies and gentlemen, you should have some vocabulary words. Some of them are to solve an equation, equivalent equations, linear equation. They will be up there. Ladies and gentlemen, circle, annotate. We had talked about that in class. Please do it. You guys will be doing it. It's good practice to do it now for when you're doing annotated notes in English. So here's a little rule. Addition property of equality. Basically what it says, ladies and gentlemen, if there's two numbers on the same side that equal each other, if you have to keep them still equal, all you do is you add the same number to the both sides. So 14 equals 14. If I add 3 to both sides, the numbers are still the same. -3, add 9 to both sides, it's 6. They're still equal. The goal is to make sure we don't actually change anything. All right, solve this equation. So we had talked about in class, and I mentioned it to you guys, that these variables here, you want them to get by themselves. You want to get everything away from them as possible. And you guys have to remember two things. What is the opposites of the order of operations? So what I mean by that is the opposite of addition is subtraction. Okay? The opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. So whatever you see over here on this side by the variable, you have to do the opposite. So what I mean by that is this is subtraction. So we want to get this 12 over to the other side. So since this is subtraction, what is the opposite of subtraction? It is addition. So you would add 12 to both sides. Okay? When you do that, ladies and gentlemen, -12 plus 12 is what? 0. Do we write h plus 0? No, we do not. We just write h equals, it's all by itself now. -27 plus 12 is -15. Remember, we're just doing adding and subtracting. You try now. All right, we want to get this variable by itself, okay? On this side of the equation, we have g minus 25. What is the opposite of subtraction? It is addition. So we're going to add 25 to both sides. Because our goal, remember, is on this side of the equation, we want to make this 0, so G stands alone. So, but if we do one thing to one side of the equal sign, we have to do it on the other side of the equal sign. Remember, this is kind of like the great divide. All right? If you do something over here, you got to do it over here. So, if we do that, we get G equals, oh, let me change that up. Change the color to, let's go blue. So G equals, and then what would be 113 plus 25? 138. Now, that looks funky if you don't like seeing that. It's G equals 138. Okay? You can plug it back in. If I plugged in 138 here, 138 minus 25 is 113. This one, ladies and gentlemen, remember, the great divide. Okay? Whatever you do to one side, so we want to make this 0, so it's plus 87. Then this side has to be plus 87. If you do that, this comes into J equals, and then this would be 84. Any questions, ladies and gentlemen? If you do, please ask in class. All right. Words, now we're doing subtraction. The equation is the same number. You can not only add, but you can subtract from both sides, and the number should still stay the same. Remember, if you guys look at this, it's a great divide, okay? Whatever you do to one side, you have to do to the other, okay? Same thing on that instance here. So let's talk about subtraction. Great divide, okay? Splitting it in half. We're going to work on this side first. So we see C plus 102. I want to get C by itself, so I have to subtract 102. If I subtract 102 from here, I got to subtract it from this side. So you end up with C equals, and oh boy, I don't have a calculator with me. Let me see if I can do this. I'll do it long math. So that would be 12, that would be 9, that would be 6, 6, 1. Do the quick math in my head. Yep, C equals 166, okay? Mental math, ladies and gentlemen, mental math. Your turn. All right, so make sure I forgot on the notes, flip it over. Please annotate that the previous exercise, the guided practice 187, on the left-hand margin of your notes, please put down that this is on page 88, guided practice, okay? Remember, so it'd be over here, so put guided practice, page 88, okay? If you guys know in the notes, you don't see this on the notes, you see everything else, so please put that on the side so we can tie it together. Subtracting. So, great divide, look at it. We want to get K by itself. In order to get K by itself, we need to get rid of this 27 by subtracting it. Alright, so if you do it to here, you got to do it to here. So, K, because that equals 0, K now equals what? 3. Same thing over here. Great divide, ladies and gentlemen. And then what you do on one side, we're getting P minus 16. If you do it over here, you got to do it over here. P equals, that would be negative 28. Now, let's move on. Multiplication and division. Now, these properties of division, kind of what we had talked about before, okay? I want to make sure you understand a couple different examples here, okay? For any real numbers, if you multiply one number on one side, then you have to do the same thing on the other. So they skip a step. They go from here to here. But what's in between here? What they're doing is they're basically doing 3 times x equals 3 times 5. Okay? They're multiplying 3 to both sides. And when you do that, what do you get? 3x equals 15. So that's what they're doing. I know they don't write it in here, but please make sure you understand that. Okay? Division properties. All right? They had... They started off with an equation of this, and then they wanted to physically reduce the 20. Now, did they have to choose 5? No, they could have chose 10. They could have chose 4, but instead they chose 5. So if you divide both sides of the equation by 5, right, what do you get? You get this would be x over 5 equals negative 4. Now, we, ladies and gentlemen, would never do this. But I want you guys to understand that when you do this, basically what you're saying is the finished equation version of this, okay, is x over 5 equals negative 4. Would we ever do that? No, we would not leave an equation like that. What you would actually do at that point is you would actually do what? Multiply by 5 to get rid of this fraction and go back to negative 20. But it's kind of, I'll show you why that's important to know that. All right, solve this equation. Oh, this is beautiful. Don't you love fractions? Oh. All right, let's set this up. First thing you want to do, ladies and gentlemen, is make this an improper fraction. So 8 times 1 is 8, plus 3, that would be 11. So this is negative 11 over 8k equals 2 over 3. Now, our first goal, ladies and gentlemen, is to do what? We want to get the k by itself. How are we going to get this k all by itself? We're going to multiply both sides by what? What number can we make this so that it's k by itself? Remember, when we have an x, a y, or a k, and it equals something, all right, what number is missing that we don't write anymore, but we know it's there? It is the number what? 1. So we want to make the number 1 in front of k. So how do we make this 1? You multiply it by its reciprocal. And since it's negative, ladies and gentlemen, I want you to multiply it by a negative, because if you don't, you're still going to have a negative 1 over here, so it's going to be a negative k. So you got to multiply it by negative, because negative times a negative is what? Positive. So if I do it over here, remember, here's the great divide. Let me go red. The great divide's right here. Okay, if I have the great divide there, I do one thing on one side. I got to multiply by negative 8 over 11 on this side. Now you simplify. And when you simplify, ladies and gentlemen, you come up with cross multiplication. Now, the reason we cross multiply is because if I multiply this out, I would get what? 88 over 88, which basically equals what? 1. Now, it's negative, so a negative and a negative would be positive. The reason you can cross multiply is, remember, is you're just going to eliminate. So this would be, these two numbers subtracting each other, that'd be 1. These two can be divided into, that'd be 1. This and this are the same thing. If you want to multiply it out and then make it 1, I'm okay with that. Just understand what you're doing. What we're doing is we're getting rid of everything here except the letter k. It's all by itself now. It is a bunch of 1s and a k. And then you multiply over here on this side. You're just going to have to go straight across the board on this. So this would equal negative 16 over 33. You're done. K equals. So the final would be k equals negative 16 over 33. All right. This one, fantastic. That was multiplication. We're going to actually do division on this one because, remember, we're going to split it in half. We want to get the b by itself. What symbol is in here? Multiplication. What's the opposite of multiplication? Division. Divide this by negative 15. Divide this side by negative 15. You want to get rid of the negative, so you have b equals, and that is 30, 45, 35. All right, ladies and gentlemen, your turn. All right, first thing I want to make sure you do, ladies and gentlemen, as we talked about, is get rid of this equation. Let's do it in one simple step. Multiply it by its reciprocal. Okay, equals 6 times 5 over 3. So when you multiply this out, ladies and gentlemen, what do you get? These cross out and they become 1s. These can be divided out and they become 1, or you can go 15 over 15. It's still going to be 1, and all you're left with is k. On this side, two things. You can cross multiply, or you can multiply it out and simplify. It's up to you. So what I mean by that is 6 times 5 is 30 over 3, which reduces down to 10. Or if you cross multiply, remember 6 over 1 is what that really is. Okay? And since it's over 1, 3 can be divided in 6 twice. This would then turn into a 1. K equals 2 times 5. k equals 10. All right, same thing over here, ladies and gentlemen. Get rid of this 3 over 2. How would you do that? Multiply by its reciprocal. So over 3 over 2. So if I multiply by the reciprocal, goodbye, goodbye, goodbye. These are all 1s, and what's left is b. So b equals, so I'm going to rewrite this so I can see it better, negative 1/4 times 3 over 2. Doesn't look like I can cross multiply, so you just do it, multiply it straight up. Your final answer, ladies and gentlemen, would be negative 3 over 8. All right, so let's talk about this equation real quick, ladies and gentlemen. Ricardo drove 780 miles. So if you go 780, okay, he drove about 3/4 of the distance. On the first day, about how many miles did Ricardo drive? Let's talk about that. Here's the equation, ladies and gentlemen. 3/5 the total distance. So if the total distance was 780, we would just multiply it by 3 over 5, and then we would have what? Letter the equation. So if we put this in the calculator, 780, multiply that by 3, then divide that by 5, you get your answer. M equals 468. All right, so hopefully you guys understood. Total distance. He drove this far. How many miles did he drive? That distance. If I asked how many was remaining, I would actually flip it over, and it would still be the same thing, about 468. Nice. Stained glass. Allison is making a stained glass window. Go ahead and read that to yourself and answer it. All right, so ladies and gentlemen, let's talk about this. Her pattern requires 1/5 of the glass to be blue, okay? She has 288 square inches of blue glass. If she intends to use all of her blue glass, how much glass total will she need for the entire project? So as I think about this, I'm thinking of 2 different aspects with this, okay? If 1/5 is the total, okay, let's see, I'm going to do some trial and error. Okay, let's do trial and error. What I mean by that is, sometimes, ladies and gentlemen, you'll put a formula in and you'll enter it, and if the number's actually smaller than what it's supposed to be, would that be ideal? So for example, sometimes on a word problem, you just shoot for the stars and put it in there and see if it works. And what I mean by that is, if in reality, if we were to get a number that says 144, okay, if she intends to use all of her blue glass, how much glass would she need for the entire project? Well, we know that she's going to need a lot of glass, okay? So if we get a number smaller than 288, then we've made a mistake. So let's try this one first. So we know the total project is X. And if we times it by 1/5, and will that equal 288? And will that give us the total glass? Let's see. If we were to solve it then, how do we get rid of this 1/5? We multiply it by what? Because remember, that's multiplication, opposite, but it's a fraction, so that is technically division. If you multiply this by 5, remember it's 5 over 1, or just 5, multiply this side by 5, what happens to this side of the equation? Well, this cancels out, becomes 1, so all you're left with is x. So x equals 288 times 5. 288 times 5. Ladies and gentlemen, that equals 1,440. If you divide that number by 5, guess what you'll get? 1/5. So that is the answer. A quick thing with class, guys. This is the first step. So these are one-step equations. Pretty simple stuff. Work on these. Work on the homework that I give you, because I need to make sure you don't switch the signs. And what I mean by that, ladies and gentlemen, is if it's multiplication, that you divide both sides of the fraction, or both sides of the equation. If it's addition, that you subtract both sides. Please remember how I did it in the beginning, and you guys do that exact same way so you don't make mistakes, all right? Until next time, ladies and gentlemen, I'll see you in class or on the next video lesson.